And welcome to the Smart Science measuring video about the Doppler effect lab. The Doppler effect is very interesting, basically saying that as something is moving towards you or away from you, the sound will change because it either compresses the wave or stretches it out, that sound wave. That's just a really basic overview of what that means. You can see at the top of the screen, the lab description just shows you a picture of what you're going to be seeing in this lab, the oscilloscope image of the moving sound waves, and then the guideline just shows you what to do. We're going to be clicking on successive wave tops, all 10 of them, starting to the left and going right. Don't skip any. It's really important to do each one. This is going to measure the gap between the waves. As the waves compress, they'll be closer together. If the waves are spread out, they'll be farther away from each other. So that measuring those 10 gaps gives you a sense of how much the waves are either compressed or stretched out. Now, does moving a sound change the way we hear it and what the sound's period is? That's a good question. Let's try to figure that out. The first thing is that we're going to pick or write a hypothesis we'd like to test. I'm just going to click on one randomly. And then we've got all these different things we can measure. Again, you have to measure the top and bottom, that's ingoing and outgoing, and compare them looks like we have 5 different speeds. We have if the sound isn't moving at all, and we have the sound moving at a very fast rate. Let me just take one of these at random and show you what it looks like and what the video sounds like. So I'm going to press play. Notice the change in sound as that car passed by us. The doo. So that's what you're thinking about. Now, remember, we have to click on the top wave for incoming. So let's start with that. And I want to click on those 10 successive wave peaks. By the way, just look at the incoming and outgoing waves. Do they match up exactly? At 0 kilometers per hour, they probably would. But let's go ahead and click on these wave peaks and see what we get for a graph. So I'm being very careful, clicking 10 times. Notice what's nice about this is it's going to give us distance measurements for wave number. Now what that means is if I've done the distance measurements for this top wave, right, and save them, and then I do the distance measurements for the bottom wave, I can actually compare the numbers even if the graphs are very similar. So the numbers should tell a story. Is there a slight difference, a large difference, no difference? Look for that in the incoming versus the outgoing wave at each different speed. Learn more about the Doppler effect in this Smart Science lab.